welcome back to our channel, where today we're diving into a mind-bending discovery that sounds straight out of a science fiction novel. A young prodigy has made a bold claim that's sending shockwaves through the scientific community. The Large Hadron Collider, LHC at CERN, has purportedly created a parallel universe. Stick around as we unpack this extraordinary claim, explore the science behind it, and ponder the implications of such a discovery. Let's get started. In a dramatic twist that seems ripped from the pages of a sci-fi thriller, the Large Hadron Collider, the planet's most gigantic and powerful particle accelerator, nestled in the heart of CERN's intricate accelerator complex, became the center of a global debate upon its activation on September 10, 2008. Swirling with controversy, it was feared to potentially spawn a cataclysmic event, ranging from triggering a new Big Bang, annihilating the world as we know it, to unleashing a voracious black hole poised to devour our very planet. Yet, when the accelerator roared to life, discrepancies, casting shadows of doubt on our perceived reality. Max Laughlin, the young genius in question, delves into the Mandela effect, proposing it as evidence that our current existence is merely an alternate version of what once was. Could Laughlin's audacious theory hold water? Are we indeed living in a parallel dimension, courtesy of the Large Hadron Collider's unseen influence? As we grapple with these questions, the line between fact and fiction blurs, inviting us to reconsider the fabric of our universe. Prepare to dive into an adventure where reality twists into the unimaginable and the line between what's possible and the realms of science fiction blur. Hidden 570 feet beneath the majestic Alps, straddling the Swiss-French border, lies a marvel of modern science, the Large Hadron Collider, LLC. Since its inception in 2008, this colossal experiment has captivated the world's imagination. Envision a 8-mile, 27 km, circular labyrinth of superconducting magnets, so frigid they dwarf the cold of outer space, designed to catapult particles into one another at speeds flirting with the light itself, all within a vacuum surpassing the voids of the cosmos. This groundbreaking endeavor, fostered by the European Organization for Nuclear Research, CERN in Geneva, Switzerland, commanded a breathtaking $8.8 billion to bring to life. Yet, the stakes are as high as the ambition, with the LHC setting the stage to revolutionize our understanding of the universe. It represents the pinnacle of human ingenuity, a collective dream of the brightest minds aiming to unlock the mysteries of high-energy physics by orchestrating proton collisions at unprecedented velocities. At the heart of this scientific odyssey, the collider wields the power to achieve what was once only conceivable in theory, accelerating particles to 99.99% the speed of light and generating temperatures in the trillions of degrees. Such feats promise to not just peek into the fabric of the universe, but to weave through its very essence, possibly opening doors to alternate dimensions that challenge our grasp of reality itself. In the grand quest to unlock the cosmos' deepest secrets and propel particle physics and quantum mechanics into a new era, the Large Hadron Collider, LHC, was poised at the frontier of discovery. Yet, with groundbreaking innovation comes the shadow of uncertainty and risk. Given the LHC's monumental capabilities, critics voiced alarm over the potential for catastrophic mishaps. Among the most chilling scenarios was the fear that CERN's behemoth could inadvertently spawn a black hole, threatening to engulf the Earth itself. This apprehension sparked a lawsuit filed at the European Convention of Human Rights, challenging the nations, including the United States, that backed the ambitious project. Despite the swirling controversy, the LHC barreled ahead, achieving its inaugural collision in 2010 with an energy level of 3.5 teraelectron volts, TeV, per beam, quadrupling the previous global record. The year 2012 marked a watershed moment for the collider with the heralded discovery of the Higgs boson, or God particle, a cornerstone achievement that validated decades of theoretical physics. However, the trailblazing discovery was soon followed by a period of silence, as the LHC was temporarily decommissioned for 2 years. When it roared back to life in 2015, it reached new heights with a total collision energy of 13.0 TeV, although it did so without the fanfare of previous years. The cycle of innovation paused once more at the close of 2018, as the collider entered another phase of maintenance, leaving the scientific community and the world at large in eager anticipation of its next groundbreaking revelations. After an ambitious 3-year hiatus filled with upgrades and enhancements, the Large Hadron Collider, LHC, triumphantly resumed its operations in April 2022. While it successfully navigated past the dire predictions of inadvertently creating a black hole, another captivating theory lingered, introduced by none other than the prodigious Max Laughlin at just 13 years old. Celebrated as a wonderkind and often cited as the brightest youth globally, Max has consistently astonished with his precocious scientific prowess. From an early age, he engineered a revolutionary device capable of generating energy independently of fossil fuels or solar power, a feat of genius, though its advancements have yet to reach the public eye for mysterious reasons. Max, who has drawn comparisons to the legendary inventor Nikola Tesla, postulates that the LHC has breached the boundaries between dimensions. He suggests that CERN's experiments might have torn through the veil of our reality, linking us to a parallel universe that mirrors our own yet diverges in unseen ways. Max's assertions extend beyond mere speculation. He points to similar endeavors previously undertaken by CERN as evidence supporting his groundbreaking claim. His theory posits that we may now inhabit a world subtly altered, intertwined with an alternate reality, a concept that challenges our understanding of the universe and beckons us to ponder the profound implications of human ingenuity. Max Laughlin's intriguing theory is interwoven with the mysterious Mandela effect, a term birthed by paranormal investigator Fiona Broome in 2009. Broome was stunned to discover that she, along with a significant number of others, vividly recalled the iconic Nelson Mandela passing away in prison during the 1900 ADC. This collective misremembering baffled many, as Mandela was, in fact, released in 1990 and later became South Africa's president until his death in 2013. This widespread phenomenon of shared yet incorrect memories was thus named the Mandela effect. Max propels this conversation into new dimensions. Quite literally, he posits that these so-called false memories aren't mistakes at all. They are remnants of our existence in a previous universe. According to Max, the experiments conducted with particle accelerators like the LHC have nudged us into a parallel universe that, while mostly similar to our own, carries subtle differences that disrupt our collective memory. One striking implication of Max's theory is that in our former universe, Nelson Mandela might indeed have died in prison, which could explain the pervasive memory many share of such an event. This discrepancy between universes offers a tantalizing explanation for the Mandela effect, suggesting that our memories might be echoes of realities from a universe we once inhabited. The Mandela story is merely one example among many that support the Mandela effect. Another notable instance involves the beloved children's book series, further illustrating the fascinating and perplexing nature of collective memory and the potential impact of universe-shifting events. Diving deeper into the enigma of the Mandela effect, another compelling example emerges with the Berenstain Bears phenomenon. Despite the clear spelling on the book's cover as Berenstain, a vast swath of individuals firmly recalls it being Berenstein. Many even assert they learned to spell it that way during their school days. Imagine the intrigue when a video circulates, showcasing a man with a copy of the Berenstain Bears book in hand. As he steps through a doorway, the title ostensibly morphs to Berenstein, Bears, before reverting back upon his exit. What could possibly explain this apparent anomaly? This phenomenon fuels the debate around the possibility that we might be experiencing glitches within our universe, or perhaps hints at the notion that our reality might be a simulation. After all, how could our physical world experience glitches? The universe is an endless frontier, brimming with mysteries that science is only beginning to explore. The existence of such unexplained phenomena suggests that there's a vast expanse of knowledge about the cosmos and the very fabric of reality that remains undiscovered. Theories about everything from parallel universes to the nature of our existence offer tantalizing glimpses, but they also underscore just how much we have yet to learn. As we stand on the brink of these cosmic questions, the mystery of the Berenstain Bears invites us to ponder the deeper intricacies of our universe and the possibility of realities beyond our own. As we navigate the complex labyrinth of our universe's laws, the enigma of dark matter and dark energy looms large, casting long shadows over everything in space. Amidst this swirling maelstrom of cosmic mysteries, there's a tantalizing question. Has CERN, with its monumental experiments, inadvertently unlocked a doorway to a parallel universe? A realm where the foundational principles that govern our existence are reshaped, offering explanations to phenomena that bewilder us, such as the James Webb Space Telescope, JWST, unveiling galaxies that appear to predate the Big Bang. The concept of extra dimensions isn't a flight of fancy, but a serious scientific postulation. Renowned minds have long speculated about the existence of realms beyond our familiar 3 spatial dimensions and 1 temporal dimension, suggesting our universe might be more intricately woven, hosting at least 1 more spatial dimension invisible to our current observational capabilities. These hidden dimensions, elusive at the energies we've managed to probe so far, might only reveal themselves at much smaller scales, synonymous with vastly higher energies. Herein lies an astonishing theoretical possibility. If these extra dimensions are real, CERN's Large Hadron Collider might have the capability to generate minuscule, ephemeral black holes. This prospect opens the door to even more speculative wonders. Could CERN not only create black holes, but also forge wormholes? These hypothetical passages through space-time could, in theory, enable instantaneous travel across the cosmos or even to other universes, presenting us with a literal portal to the unknown. As we inch closer to unlocking these secrets, we stand on the precipice of a new era in our understanding of the universe, where the lines between science fiction and scientific fact become ever more blurred. The Large Hadron Collider is the world's largest and most powerful particle accelerator. Nestled beneath the border of France and Switzerland, the LHC accelerates particles to near light speeds before smashing them together. These high-energy collisions allow scientists to probe the fundamental structure of the universe. But could these experiments have inadvertently opened a door to a parallel universe? Let's take a closer look. Enter our young genius, a child prodigy who has captured the attention of the global scientific community. According to them, anomalies in recent LHC data suggest we've brushed against the boundaries of another universe. These aren't claims made lightly. They're based on observed discrepancies that defy current scientific explanations. Could we be on the brink of the greatest discovery in human history? As expected, this claim has its skeptics and supporters. Some scientists argue that the data could be explained by less sensational means, while others believe we're not far from proving the existence of parallel universes. This segment of our exploration delves into the scientific community's reaction, highlighting the debates and discussions that have erupted in light of this claim. What if it's true? The existence of a parallel universe could revolutionize our understanding of the cosmos. It could redefine physics, challenge our perceptions of reality, and even offer new insights into the nature of our own universe. We'll explore the potential implications of this discovery, from the theoretical to the profoundly existential. Regardless of the outcome, this claim has ignited a renewed interest in particle physics and the mysteries of the universe. We'll discuss what's next for the LHC and other particle accelerators around the world. How will this claim influence future experiments? And what steps are scientists taking to either prove or disprove the existence of parallel universes? Delve into the building blocks of our universe. explain fermions, bosons, and the fundamental forces that govern their interactions. This segment sets the foundation for understanding how the LHC can probe the deepest questions of the universe. Detail the major discoveries made by the LHC, emphasizing their significance. Discuss how the Higgs boson lends mass to other particles and other breakthroughs that have contributed to our understanding of particle physics. Offer an in-depth explanation of the mechanisms behind particle acceleration and collision within the LHC. Illustrate how protons are accelerated to near light speeds and the technology that makes this possible. Explore the theory behind parallel universes, including the many worlds interpretation of quantum mechanics and theories arising from string theory. Discuss how these theories propose the existence of other universes beyond our own. Quantum mechanics introduces concepts like superposition and entanglement that challenge our classical understanding of the universe. Discuss its role in theoretical physics and how it might support the existence of parallel universes. Examine specific data anomalies from LHC experiments that cannot be explained by current physics. Discuss how these might suggest the existence of phenomena beyond our current understanding, including parallel universes. Feature discussions with physicists working on or associated with the LHC. Explore their perspectives on the possibility of discovering a parallel universe and the significance of the LHC's research. Highlight how the scientific community approaches extraordinary claims. Discuss the processes of hypothesis, experimentation, and peer review in the context of groundbreaking claims like the discovery of a parallel universe. Focus on the engineering achievements that make the LHC possible, from superconducting magnets to the cooling systems that keep it operational. Discuss how these technologies were developed and their importance to the LHC's success. Consider the broader implications of discovering a parallel universe. Discuss how such a discovery would impact our understanding of existence, identity, and our place in the cosmos. Examine how the LHC and the idea of parallel universes have been represented in popular culture, from films to literature. Discuss the impact of these portrayals on public understanding and interest in particle physics. Look ahead to future experiments planned for the LHC and other particle accelerators worldwide. Discuss how these future projects aim to further our understanding of the universe and the potential for discovering parallel universes. Highlight the international collaboration behind the LHC, showcasing how scientists from around the world come together to push the boundaries of knowledge. Discuss the impact of LHC discoveries on STEM education and how they inspire future generations of scientists, engineers, and thinkers. Explore the challenges of funding large-scale scientific projects like the LHC. Discuss the role of international cooperation and the impact of political decisions on scientific advancement. Address public concerns about the safety of high-energy particle collisions at the LHC. Discuss the extensive safety studies conducted and the scientific consensus on the safety of these experiments. Separate myth from reality in the discussion of the LHC and parallel universes. Debunk common misconceptions and highlight the scientific basis behind the search for parallel universes. In this segment, dive into the scientific debate over the existence of parallel universes. Present both sides of the argument, including skepticism from the scientific community and the theoretical underpinnings that suggest such universes might exist. Highlight key theoretical models, such as the many worlds interpretation of quantum mechanics and string theory, that provide frameworks for understanding how these universes could coexist with our own. Explore how research conducted at the LHC could influence the development of quantum computing. Discuss the relationship between particle physics and quantum mechanics, and how discoveries at the LHC might lead to advances in quantum technology, including quantum computing, quantum encryption, and other applications that could transform computing, security, and information technology. Address the challenges and limitations faced by researchers working with the LHC and other particle accelerators. These include technical challenges related to the machines themselves, the difficulty of analyzing vast amounts of data produced by particle collisions and theoretical challenges in interpreting results and integrating them into our existing framework of physics. Discuss the efforts by CERN and the scientific community to engage with the public and educate people about the importance of particle physics. Highlight outreach programs, public lectures, open days at CERN, and online resources that aim to demystify the work being done at the LHC and inspire future generations of scientists. Welcome to Blesovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blesovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blesovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.